Well, hello again everybody. Well, today is a really horrible winter's evening. It's blowing a gale outside and raining cats and dogs and it's absolutely freezing. It's horrible. So I'm nice and safe and warm and cosy in my little workshop here. And I did mention earlier this week that I got this Velleman signal tracer kit. I just thought that it would be quite enjoyable just to spend a few hours building this, and maybe I can tell you a little bit more about it as well. So for those playing at home, it's a Velleman signal tracer stroke injector, and their model number is K7000. So I just got some marketing bump there. It says that it's got a 0.5 watt output into an 8 ohm speaker. We require a soldering iron. Well, we've got lots of them. It's a difficulty rating 2. That might be a bit beyond me, that, literally. We'll see if I can manage difficulty rating of 2. And it requires a 7 to 9 volt AC supply or 9 to 12 volt supply. So I'm guessing we're going to try and run this off a 9 volt PP3 battery with a bit of luck. And it comes with an instruction booklet in, I think that's French, which is no use to me because unfortunately I can't speak peasant. Get rid of that. Right, here we go. Signal tracer injector K7000 simplifies audio troubleshooting. Well, the first page is pretty much taken up with the specification which we mentioned earlier. Output power 0.5 watts into 8 ohms, power supply 7 to 9 volts AC, 9 to 12 DC. Dimension of the circuit board, I'm guessing 60mm by 53. And the injector specification, it goes to 0 to 2.5 volts RMS, which is adjustable. Output impedance 1.5 kilo ohm at a frequency of 1 kilohertz. So that's going to be a nice little screechy audible tone. And this is the tracer sensitivity is 3.5 millivolts to 10 millivolts sensitivity. Gain is plus 40 dBs, and the input impedance is 50 kilo ohm. Which 50 kilo ohm. I thought it might have been higher than that. I think the original the original signal tracers would have used valve tubes, and I suspect their input impedance was probably much higher than 50 kilo ohm. I don't know that, but I expect it was. And I've also known that there is some better signal tracers out there that have got, again, another FET transistor as their input. So again, I'm guessing that they can achieve much better than 50 kilo ohm. But given that this is my first signal tracer, we'll have to see how we get on, won't we? So in the construction information here, we've got a little picture of all the components. And I can see here they've got a little tick box next to them, so when you've actually installed them you can put a tick next to it and you know you've done it. So I'm guessing that this is the construction sequence. Yeah, even people like me can make a mistake, so it's quite nice to have a book with a construction sequence in it, so I have no complaints there. So the first thing we've got to do is put some Zener diodes in, then we've got some general rectifier diodes, 1N4007s, then some resistors, then some dip packages and capacitors, and then finally onto this page where we put in some potentiometers. Test and usage. Okay, so it just tells us how to use it, and it gives us some examples there of what the probes might look like. And we get a circuit diagram and a diagram of the component layout. So we get a proper little manual there, something to read, and that's all quite useful, isn't it? It's quite nice to have a little manual, and especially for any new players out there. I suspect this is going to be a nice little project to build. So we don't need that now. Let's have a look what else is in the box. So we've got some general marketing bump here. It looks like Velleman are also doing some kind of robot kits. That looks quite good fun. Oh, and they're doing a kit for a 3D hackable printer. Oh, that's quite nice. 3D printer. Some Ethernet relay card. Oh, I'm actually quite interested in that myself. You can plug this card into, you can plug this Ethernet card into your computer, and you can switch relays on and stuff like that. 4 digital inputs and oh, it's got analog inputs. That looks like quite an interesting thing. I might look into that, the Ethernet relay card. What have we got here? Oh, a warranty. No, that can go. And they've supplied all the resistors and the diodes here, and they've put them on a little bandolier for us. So maybe that shows the sequence in which we install them, which I think it does. And it's going to help stop me from losing them. So well, that's quite a good idea, that, isn't it, to put them on a little bandolier thing. So here's a circuit board it comes with, which is FR4 fiberglass material. It's got the name Velleman on it, and it says P7000, which is what our kit is. I can't tell if those are just the bare pads there, if that's gold or copper plated. It's a little bit hard to tell. It looks more like it's just bare copper. but I suspect they are gold plated, I'm not sure. Okay, so we've got a little bag with some through hole pins here for doing our wire wrapping too. And just various capacitors and things like that. Got some fixing screws here for the potentiometers. And where are the potentiometers? We want to have a look at them, don't we? They're exciting. We've got a 47k potentiometer and a 4k7. So look forward to getting them the wrong way around. A solder iron with a small tip, yeah, I think we've got that. We need a wet sponge or cloth, yeah, got that, check. We need some resin cord solder, check. Diagonal cutters, yep. Some fine needle nose pliers, yes. And a multimeter might be handy, check. I think we've got all that stuff somehow. Oh dear, I've just noticed it says make sure your skill level matches your experience to avoid disappointment. Might be some disappointment. You know, I wish somebody had given me that advice before I met the wife. Oh, I don't know if they are gold plated. It actually feels a little bit stubborn. Might have been a good idea if I'd have just given this circuit board a little bit of a clean before I actually started to assemble it. Yeah, I probably should have done that. Maybe I'll do that in a minute, give it a wipe over with something. When you're trimming the legs off components, grab hold of them rather than just cutting them off and letting them wang somewhere, because one day you'll cut the leg off a component and it'll end up going somewhere it shouldn't and shorting something out. So whenever you're cutting legs off things you're building, just make sure you dispose of each one, and then you know it's been it's put away in a position of safety then, rather than, you know, getting caught up somewhere to leg you out in the future. The lead spacings on these components seem a little bit, well, mainly for the resistors, they actually seem a little bit wider. Normally I'm pretty good at bending the legs on, pre-bending the legs for resistors, but I seem to be getting it a bit wrong today, so I'm kind of wondering if some of these are, yeah, not quite the standard pitch for resistor legs. So we've next got R4 and R5, which is R4's 22k and R5 is 100k, which is what it is. Just looking at this board, I think it is actually quite cheaply made. I don't think it's an exceptionally well made board, but oh well, doesn't matter. Sure, it's good enough for what we're doing with it. So the next ones we've got to do are R6, which is a 5k6, which is what that is, and a 1.5k, so that's them two. Oh, just noticed I've cocked up already, wasn't I? I was happy just stuffing my resistors in the hole, and I've just noticed I've put one in the wrong place. That is actually not, I thought that was going to be R6, but it's not, so more on. Too much talking to you boys and not enough concentrating. So where should that have gone? That was R5, that's our 100k, so that is R5. Let's find where he should have gone. He should have gone there. Yeah, these boards are definitely dirty, they're not taking solder that easily. I don't think I've got anything to hand to clean it with. I think again another tech tip is to use an old pencil rubber to clean your circuit boards, particularly the ones that were for erasing ink, you know, the ones that are abrasive. You can actually buy proper PCB cleaning rubbers, erasers, whatever you Yanks want to call them, but they're quite expensive. I haven't got one. Maybe I should invest in one if I'm planning on doing more kit builds. God, I made a dog's dick of that. Well, that's all our resistors done, so the next thing we've got to do is we've got to install the IC sockets, and then it's onto the capacitors. You know what, I absolutely love installing IC sockets. I don't know why, there's just something about it, it's just so pleasing. Especially when you get it right and they sit down. And there's nothing worse than when you put one of these dual inline packages and you haven't got it quite sat down, but you tack the legs down, and yeah, and then you look at it afterwards and it's kind of a bit on the piss. That always annoys me massively. So for the capacitors we've got 4 ceramics, which are C1, C2 and C3, and they are all 100 nanofarads. So we're looking for something with 103 written on it, and it just so happens we've got things with 103 written on it. So we'll have them. Let's put all them in together. C1, where's that? Where's C1? I can't even find C1. It's a bit of a fail, isn't it? Where's C1? C2, oh there it is, right in front of me. Seen one, you've seen them all. That's what my missus says. So we need some transistors next, which it says a BC547, which are just basically jelly bean NPN, aren't they? So let's find them. I don't know about you, but I absolutely love building kits. The hours just fly by, and they are pretty educational. You know, it's a great way before you've got the confidence to tackle your own projects. Well, no, I'm not just going to say that. I mean, a lot of us haven't got time to do our own electronics projects. I mean, I struggle to fit stuff in. And sometimes it's nice, you buy an electronics kit and somebody's gone to all the hassle of buying the parts for you, giving you the instructions. So, you know, rather than just spending hours on RS looking at capacitors and resistors and wondering what to buy, you can order a kit, and you can probably order some of these kits cheaper and quicker than you can go on RS and buy the parts for. So yeah, there's a lot to be said for building kits. I know probably some people look down on it saying, oh well, I'm an electronics engineer, I can design my own stuff. Well yeah, you can, but you know, you can bake your own bread, but I don't do that either. If you do like to bake your own bread, then there's not saying you shouldn't do it. I mean, go ahead, bake away, but yeah, not for me. Now when I'm installing transistors, I generally like just to solder one leg in first. Doesn't really matter which one, but you solder one leg in first. I think this is the base on here, and then I like to just straighten them up, because again, transistors that aren't lined up, that are a bit on the piss, that always annoys me as well. I'm often a little bit OCD about installing components on circuit boards. Not always, I mean, I'm just kind of bashing this out, but you know, I do like to get it as right as if I can. Things that like resistors that are out of line and stuff like that, it always annoys me. Okay, so we've got our transistors installed there, T1 and T2. Let's see what we've got next. Alright, so we've got some PCB pins to install now, so let's ram them in. So also included in the kit, we've got these Weimer style capacitors, and these are rated at 250 volts, it's 100 nanofarads. So I'm going to guess that these are something like maybe the input and output coupling capacitors. So they're trying to give you a little bit of safety there, a little bit of isolation. So they've got a higher voltage rating than the other components. Let's just double check that on the circuit diagram. They call me a liar. So C4, what was C4? Yeah, C4 is the input to the audio amplifier, and let's see where the output is. C5, alright, so yeah, they're doing just what I've said. Basically, the inputs and the outputs to our PCB, they are protected via high voltage capacitors, which you may want if you're probing inside well, maybe a valve circuit, a valve amplifier for something. I know some people on the in the comments, I've looked at some people who've built these online, and they have said that, you know, they've replaced these, rather than being 250 volts, they've put something like 1000 volts in, because they do work on valves and stuff like that. So maybe we'll increase the rating of these capacitors. I'm not going to do it now, we'll just put these in. Okay, so we're on the penultimate vinegar stroke now, and we've just got these two potentiometers to install, so we better make sure we've got them right. So what's that one? That's 4K7, which is R1. So let's put him in. Or her. I don't know. What sex are resistors? No idea. I think they might, yeah. Oh, well, potentiometers, yeah. They've got to be male, haven't they, really? Yeah, so then, sorry. We'll put him in. I was right the first time, so we'll put him in. And we will put the 47 in. Let's just double check it is 47. Hard to read that. Yeah, it is 47K R2. So they can go in as well. So just looking at this is actually designed to be an AF probe, so it's actually designed for working on stuff like audio stages, and there's absolutely nothing wrong with that, but I actually wanted a probe that would work on RF circuits as well, because I wanted to be able to probe things like, you know, IF stages on radios. And yeah, that's what you want for radio work. Now, it's not the end of the world, because the main part of this, which you can use for an RF and an AF signal tracer is the actual amplifier. So that's what we've got here. We've got an amplifier, and we've also got a signal generator which creates a sine wave. But if we want to use this for RF, we've got to have a slightly different arrangement, which is quite easy to do. I mean, rather than having a sine wave output, which is what this has got, a 1 kilohertz sine wave, what you can actually do is just have a 1 kilohertz square wave. But the thing about having a square wave, if it's got a very fast rising edge, it's very rich in harmonic content, and you'll actually find that that square wave, even though it's 1 kilohertz, it'll actually still be emitting, you know, radio waves because it's got a sharp edge. So what you really want to do is you want to build yourself. You can often do it just with a NOT gate with the inverting output connected to the input, maybe with just a resistor. You want something that will oscillate and create a very sharp edge. And then what you use a Diode Detector probe wired to the input of this. And what that will do is it'll detect the RF input, and they use a germanium signal diode to detect it, rectify it. And then you can pick up the audio and you hear that through the speaker. So what we will do at some point in the future, not today, we will build an RF generator, and we'll also build the RF detector probe. So that'll be a little project. Maybe we'll do that next week. So I've just been rummaging around in my junk box, and I've just found this crappy little speaker, which it's not going to be very good, is it? I think it actually came from a PC cabinet, so as you can imagine that this is really going to be a quality item, but it's all I've got, so it's going to have to do. It's a little bit annoying that you can hear the audio oscillator in here. I can hear the 1 kilohertz tone even though it's not kind of connected. So I'm just holding the speaker up to the microphone of the camera. Can you hear the 1 kilohertz tone? So I'm just going to ground out the body on this pot. You see it goes away. So this pot needs a little ground strap putting on it. I'm thinking maybe both of these do. One of these controls the output from the oscillator, and the other one is the audio tone. So I think it's actually probably easy as anything to take a ground wire off here and just string it up to the back of that pot, which is what I'm going to do now. Okay, so I've just put this ground strap on the back of the volume potentiometer, and that's just killed the 1 kilohertz test tone that I could hear coming through the audio before. So obviously there was some pickup, maybe some capacitive coupling to the back of this can, and that was getting onto the input to the volume control. So I've just strapped that down to ground the case of the potentiometer, and that's killed it. I've got this turned all the way up now, and can't hear anything. So yeah, that little Billy Bodge worked. Well, it's a couple of hours later, and I've gone ahead and I've just kind of assembled this, or at least I've got the circuit board together and some connecting wires and stuff like that. I don't know if you remember, but a few weeks ago I was messing around with my spectrum analyzer and I had to repair it, and at one point I lifted it out of the way and I found this probe. Now what this is, it's actually a demodulation probe, which is actually just what I want. Basically a demodulation probe, all it actually is it's a diode and a capacitor. So, you know, I said I was going to have to build one of them, didn't I? And if I wanted to do some RF detection, well, luckily I've found one. Now, this actual demodulation probe, it's actually come with some banana plug leads on it. I didn't want to cut the leads off and put a BNC on or anything like that. So what I've done is I've assembled the signal tracer using these banana plugs. So if I just put my finger on there, hopefully you can hear some mains pick up. So what this is doing, I've got this demodulation probe and I've got this wired up to the input to the signal tracer. So that will detect not only audio, it should also detect some RF. But I do fear that maybe the gain on here isn't really high enough to work on RF sections of the radio. But maybe we'll, that's something I'm just going to have to figure out later. So that deals with the receive part of the signal tracer, but of course there's the other part of the signal tracer that needs to inject a signal. So again, what I did was I had a route round in the junks box and I found this, I think it's RG, is that RG174, something like that? yeah, RG174, which is basically just a very thin coax. It's not much thicker than, I don't know, like a 2.5mm square cable or something like that. And also in the junk box I found just an old test lead prod off you know, one of those £2 meters you can buy on eBay, £2 digital meter. So the meter was broken, but I always keep the wires and the probes because occasionally they're handy. So I took the test prod off it. So we've got the screen coaxial cable here going back to the output of the sine wave from the signal tracer. So again, that's going to a couple of banana plugs that I've wired on. I've got a ground here, that's wired to the ground side of the coax, and then the ground comes all the way up here, and then I've just exposed the inner core of the coaxial cable, and that's connected to the end of the well, the pointy bit. So if I just bring these two probes together now, so we've got a signal coming out of here, a sine wave, and then we've got a detector in this hand, so we put them together. And that's what we get. So I'm anxious to give this a little bit of a go on a radio now, so let's grab a radio and see if we can do anything useful with it. So I don't know if you remember last week I bought a couple of CBs that were sold as spares of repair, and I don't know if I did try this Midland 301. So here's a Midland 301 CB radio, and well, the display lights up, but it doesn't appear to do anything apart from that. You can turn the volume up, but you don't hear anything. You try and key the radio up and it does nothing. Turn the RF gain up, I'm just going to turn the squelch right down. But basically we're not getting anything out of the speaker. So I thought it would be a good opportunity just to see if there's any life in the radio. Now I've been watching some of the other people's videos on repairing CBs, and it seems like one of the first thing that people do is go straight to the audio amplifier, because the audio amplifier is often common to both the transmit and the receive circuit. So the audio amplifier on this radio is down here. Now the volume, as I say, it's all turned up fully and I can't hear anything. And if we just use our signal tracer now, what I'm going to do is I'm just going to connect our signal tracer, and I'm going to connect the input, the demodulation probe, and we'll just go on the actual speaker. And I don't know if you can hear that, but basically I can't hear anything. So have we got a duff speaker? I've got no idea at this stage, but I do know where the audio amplifier is. So what I can do is I can just probe I'll probe some of the pins on the audio amplifier. Don't know what any of them do. I'm just going to prod around and see what we can hear. So there's nothing there. There's nothing on that one. Oh, and we've got a little bit of a hiss on that one. Let's keep going. Nothing on that one, nothing on that one. And we've got a bit of a hiss on that one as well. So that hiss just kind of sounds like static, but or white noise. It's not mains hum. So are we receiving something? Well, let's just try the tuning switch. So I think that I'm on the output of the audio amplifier now, and the audio amplifier, it's certainly responding to a volume control. And if I switch between channels, I'm on channel 18 there, let's just choose another channel, we get a change, so we're getting a pulsing noise. And I just remember from the last CB that I played with, I think it was something like channel 18, in my room I got that pulsing noise. I don't know if it's something like the Wi-Fi router in here, but certainly I can just tell by very quickly using this probe, no voltmeters or anything, there is actually a little bit of life in this radio. But as I said, there is nothing coming out the speaker, but there is something coming out the audio amplifier. We can trace that signal through a little bit further. It looks like it goes through, well, it looks as though it goes through some capacitors, and it goes to, well, it looks as though it goes to the PA switch on this front of this radio. So it's got a PA or a CB. So let's see if we can trace it through to their PA or CB. So the signal definitely gets up to this PA switch, and then where does it go to from the PA switch? Can I tell? Well, it looks as though it goes back to the speaker via some jack plug connections. Well, one's a PA speaker connection, the other's the external speaker connection. So I'm not sure which is which, PA or external speaker. So is the signal going to the external speaker? Well, it's going to the external speaker connection anyway, but for some reason it isn't getting from the external speaker connection, because when I probe the speaker there's nothing. So my quick and dirty diagnosis is that there's perhaps something wrong with this. It's a changeover, it's got a changeover switch on this speaker connection which disconnects the internal speaker from the radio and connects the external speaker. So I trace the fault to somewhere around this auxiliary speaker output, this external speaker, and I can go, this is a switch type speaker, and I can go on either side of the switch here. So the switch seems closed, so that should actually be putting some audio now to our speaker. But I also have the circuit diagram here, and I could see that there's this 2-watt resistor that's in series with the speaker. So I just found the top of that resistor there. And I found that there was no signal, but if I wiggle it, oh, and now we're working. So I'm not touching the signal tracer anymore. So basically we've got a bad joint, and that was found using this signal tracer. So let me see if I can get the speaker to work again. There we go. So nothing more wrong with this radio. Well, initially there's nothing wrong with it apart from a dry joint, obviously a bad joint in the audio path. So just to round everything up, I think that signal tracer kit build was really a lot of fun. Definitely helped a cold winter's evening fly by. £13. I think it's a really useful bit of test equipment. I wish I'd found them years ago, because I've never used one before, and I'm sure that with a bit of practice it'll be a really useful tool. So I think, well, as always, I think for today that'll do. But thanks very much for watching, and I hope to see you again very soon. But until then, bye for now. Thank you. Bye bye for now.